Okay, so I'm going to show you a shortcut to your derivatives, which y'all are going to kill me because you're going to want to know why I didn't tell you how to do this before. And the answer is you need to know how to do it the hard way before I give you the easy way. So you're going to love this. Here we go. So I'm going to show you the long way here using the difference quotient. And so to find your derivative, f prime of x, you're going to take anywhere there's an x, and you're going to put it in x plus h. And so that's your f of x plus h. And then you're going to subtract your f of x. So that would be x squared plus 1 all over h. And so then square this. You get x squared plus 2xh plus h squared plus 1. Distribute your negative, minus x squared minus 1 all over h. Then you can cancel out a few of the terms. And then the terms that are left over, we're going to factor out our h. And so we get h times 2x plus h all over h. Your h's cancel, and you're left with 2x plus h. Then to actually finish off the derivative, you're going to find a limit as h approaches 0 of 2x plus h. So 2x plus 0 means that our derivative is equal to 2x. So here's a shortcut that I propose. So instead of going through all of that, all you have to do is take the exponent and swing it down in front of that variable term. And so we end up with a 2. And if there's something in front here, then a coefficient in front, then you multiply the 2 to that coefficient. And then we have x, and take away one of the x's here. So since it was x squared, it becomes x to the first. And any constant you leave off, because technically this is x to the 0. And if I swing 0 into the front here, it becomes 0. And so any constant's going to disappear. So your derivative, with very little work, is 2x. And this matches what we came up with over here. Now you're irritated. But, having said that, you should love me. So let's look at this section here that you complained about that I didn't give you enough room for yesterday. Now you have plenty of room. So we're going to take 2, and we're going to swing it and multiply it to the 3. So 2 times 3 is 6, x to the first. And then we're going to take, technically there's a 1 here. We're going to take the 1 and swing it and multiply it to negative 2. So 1 times negative 2 is negative 2. And then this is x to the 0. We don't write x to the 0. There's your derivative. I love this. And then for this one, same thing. I'm going to take 2, multiply it to the 2. So I get 4x to the first, because I'm going to do 1 less. And then this is to the first. So I'm going to multiply the 1 to, technically there's a negative 1 in front. So we get minus 1 x to the 0. We're not going to write x to the 0. There's your derivative. Number 4, take your 3, multiply it to the negative 4. You get negative 12 x to the second, because I'm going to do 1 less. And then this is to the first. So I'm multiplying 1 to the 7, and I get plus 7, and then x to the 0 we're not going to write. And then this is the one that gave you the most heartache of all. 3 times 8 is 24, x to the second, 1 less. Then 2 times negative 6, so it's negative 12, x to the first, 1 less. Technically that's a 1, so 1 times 4 is plus 4, x to the 0. We're not going to write x to the 0. And again, to remind you that the constant goes away, technically this is x to the 0, which has a value of 1. That's why you don't see it. But that exponent of 0 gets multiplied with a constant, which makes 0, so we don't write it. This is the derivative as h approaches 0. You're welcome.